Good afternoon, class. Good job finding this first video that you're going to watch today. Sorry that I'm not with you to be able to walk you through this. But we are going to be looking at some skills that we're going to need. This would have been part of last chapter, but we didn't want it to get too long. So we're going to take a couple days to look at some skills that we want to make sure we have as we head forward. You can see that this lesson is called Multiplying Polynomials. The standard is I can multiply polynomials. So for our warm-up, we just want to review some multiplication in general. Hopefully you can take a second here, pause the video, and answer the first 3 questions for sure. Alright, so when you did number 1, 6 times 8, hopefully you know that's 48. Otherwise you would have a scientific or baby calculator, but it's good to have these math skills. 5 times 9 is 45. Okay, so when we talk about multiplication, we're adding 6 groups of 8 together, 5 groups of 9 together. One place we use this is to find the area of things. So you can see that next in number 3 we find the area of a rectangle, which hopefully you remember is either base times height. Some people talk about it as length times width. Any which way, finding the area, if we know the length of both sides, the 4 and the 7, we multiply them together. So the area of this rectangle is 4 centimeters times 7 centimeters, which would be 28 centimeters squared. Now the reason we review that is because as we get into this lesson and multiply polynomials together, which we'll talk about what that is in a second, we're going to use this idea of finding area. And so I gave you a more complex problem next, and you could have typed it into your calculator, and if you did, you found that it was 5,208. But more importantly, I want to show you another strategy of how we could have done this. Now, this is a way a lot of younger kids now are being taught multiplication, so it's been a change in kind of how you probably learned it. Having said that, if we take the 60, and 62, sorry, and we say that this has a side length of 62, and then if we take the 84 and say this, so this is 62, and say this is 84, really we're finding the area of that big box. Having said that, again, I would need a calculator for that. So then I think about, okay, what could I do? Well, isn't it true that 60 plus 2 is the same as 62? So if we can take a number and break it down into 2 separate pieces, then we will still be able to find the area, but in a smaller way. Same thing, if I take 80 plus 4, that's the same as 84. Now the reason we do this is because if I just look at this box right here, this first box, we can see that it has a length and width of 60 and 80. And I actually can do that without a calculator because I know 6 times 8 is 48, and then there's 2 zeros, so 4,800. Now separately, if I just want to look at this blue box right here, I can say, okay, it's got a length of 2 and a width of 80. And again, I can do 80 times 2 without a calculator because 8 times 2 is 16, and then I put a 0 on the end. So what I'm in essence doing is I'm finding the area of each of these individual boxes. So if I take this green box, it would be 60 times 4. And again, I know 6 times 4 is 24. Put the 0 on the end, so this is 240. And last but not least, I would find the area of this last box, which would be 2 times 4, which I know is 8. Sorry, I made those numbers kind of dark. So you might be thinking, well, this is a long process, and it is. You wouldn't actually multiply 62 times 84 this way, most likely, but it's going to be the skill we're going to use today. So I'm using this to kind of show you the process. Having said that, if I know that the yellow box is 4,800, the blue box is 160, the green box is 240, and the purple box is 8, if my ultimate goal is to find the area of this entire box, then I can just add all 4 of these numbers together. So if I do 4,800 plus 160 plus 240 plus 8, that will be the same as the 62 times 84. So now when I look at this, again, I'm going without a calculator. The 4,800 is the biggest number, so I'm actually going to add these two together first. 240 plus 160 is 400. Add the 8, the smaller number, so plus 8 is 408. And now I can take the 4800 plus 408, and I get 5208, which is the same as what you probably got when you multiplied it on your calculator. So again, this strategy right here is going to be called the box method. And again, it may not make sense when we just have numbers, but it is going to make sense to use once we have these things called polynomials. So before we get into the actual lesson, I do want to make sure we understand what a polynomial is. So we are going to define it. So on this line, a polynomial is an expression that has a variable and coefficients. So we're going to write that down. An expression that has variables and coefficients. And then another key about it is that the exponents cannot be negative and they must be integers. So we can have exponents. We could have like x squared, for example, but the exponents can't be negative and must be integers. And remember, integers are whole numbers, so they can't have decimals or be in fraction form. So that's what it is in words. An example of a polynomial would be like the quadratics we've been looking at, so x squared minus 4x plus 7. So it can have multiple terms. Each of these pieces is called a term. Could have 2 terms, could have 3 terms, could have 1 term, right? It could just be 5x as an example. It could be 4x minus 3 as an example. So it can have multiple terms, but it has a variable, and if it has exponents, they can't be decimals or fractions. So that's what a polynomial is. Alright, so I decided to make a bunch of shorter videos rather than longer ones. So now I need you to go back to the Thursday, April 26th folder on Schoology where you found this video and click on the video called Lesson on Multiplying Polynomials, because now we're going to get into the lesson. And you're going to use that video to help you get through the backside of this worksheet. Thank you.